طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Any questions before we proceed? Any questions before we proceed? طيب. So what did we do so far? In section 1, we looked at 4 rules. We looked at the product rule, the sum rule, the subtraction rule, and the division rule, right? And we looked at some applications. So what we will do, inshallah, in section 2, is we will look at another way of, not another way, but basically we will look at one principle that is used to prove certain, sometimes even very interesting results that you might not think it can be proven, but we will see it will be proven. Okay, it's very nice. It is called basically the pigeonhole principle. The pigeonhole principle. Today, inshallah, we will take a pigeonhole principle. We'll generalize pigeonhole principle, and then we will look at some really interesting examples. So let's start with the pigeonhole principle. If k is a positive integer and k plus 1 or more objects are placed into k boxes. So I have k plus 1 or more objects. Well, I have k boxes. Now, the result says there is at least one box containing 2 or more of these objects. There is at least one box containing 2 or more of these objects. طيب. Now, this looks intuitive, صح؟ يكون عندك k plus 1 objects وعندك k boxes, if you want try to distribute the k plus 1 on or more on the boxes, you will have to have at least one box with 2. If you try to do a direct proof, you'll feel tired. Okay, the easiest proof for this is basically indirect, using contraposition or contradiction. So let's use the contraposition. Okay, so this is by contraposition. By contraposition. Type. How should I start? If I want to prove this by contraposition, how should I start? Negate which statement? لا.
K plus or more, only K is the maximum.
لا. What do I negate? Yes.
There is no boxes containing 2.
أيوة, the negation of this. Because it says if k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of these objects. Huh? So if I want to take the contraposition, I need to negate the necessary condition. صح؟ اللي هو ايش؟ انه there is at least one box containing 2 or more objects. What's the negation of this? لا. طيب شو يعني no box contains 2 or more؟ يعني all boxes contain at most one, صح؟ Right? So by contraposition, assume that each of the k boxes contains at most one object. طيب هلا وين النيجيشن الثاني اللي راح نوصله او وين الكونتراديكشن؟ ترى شبه خلصنا، البروف انتهى. Assume that it is not the case that at least one box contains 2 or more objects. no, at least contains two or more objects, which means إيش? Which means that each of the K boxes contain at most one object, صح؟ طيب وين ال contradiction أو ال لا مش معقول لهلا مو شايفينه. No.
There is K items.
At most there are K objects. مش احنا بدينا ب K plus 1 or more. احنا we started with K plus 1 or more. طيب if we negate this the necessary condition, which is انه each box contains at most one object, we will end up with how many objects in total? We'll end up with K, صح? So this means that أو implies أحسن means this implies that there are a total of at most K objects, which is basically the negation of the sufficient condition, and basically that's it, صح? That's the end of the proof. As you can see, the indirect proof is actually much easier than if you try to come up with a direct proof, okay? Than if you try to come up with a direct
So we are proving the contrapositive.
Yes, we're doing the contrapositive.
By the contrapositive, we are negating the condition only. Then.
Yeah. So we negate. So instead of if P implies a Q, we are proving if not Q implies not P. Okay. That's why it's an indirect proof, right? طيب. So now, as a corollary of this, and we have seen this maybe I talked a little bit about it previously, a function f from a set with K plus 1 or more elements to a set with K elements is not one-to-one. How can I prove this using the pigeonhole principle? How can I apply the pigeonhole principle on this corollary? Go ahead.
The second set of K elements, one of them will take at least.
Exactly. So basically, the first set will be considered as your object, صح? The elements in the domain will be considered as your objects. والboxes ايش راح يكونوا؟ elements تبعون الكودومين. So by the pigeonhole principle, there is one box in the codomain, or there is one element in the codomain, which contains at least how many objects or elements? Two. So this means that two different elements are mapped to the same element in the second set, صح? So that's why it is not one-to-one. Excellent. طيب. So يلا هاتوا لنشوف شطارتكم. Raise your hands. How many people do we need to ensure that two of them have the same birthday, day and month? Gregorian year. حسب ما الناس تفكر هجري بعدين. 366. 366. In a leap year, there are 366 different days. In the leap year, اللي هي February بيكون 29, صح؟ That's why we need 367, right? So it's basically 366 plus 1, which is 367. 367 people, right? But how many English words do you need to ensure that two of them begin with the same letter? How many English words do you need to have to make sure that at least two of these words begin with the same letter? Two. So is Zuar Do they begin with the same?
Two of them begin with the same letter.
Yeah, two of the words begin with the same letter. How many words do you need to have at least to make sure that two of them begin with the same letter? Yes. Huh? 27. لأنه أنا عندي 26 letters in English صح؟ فif you give me any 27 words, any set of 27 words will have at least two words with the same letter. So here I'm going to say 26 plus 1, which is 27 words. طيب اللي بعده. How many students must be in a class to guarantee that at least two students receive the same score on the final exam if the exam is graded on a scale from 0 to 100, from 0 to 100 points? And here we don't accept halves. The score should be an integer. Okay, the score should be an integer. How many students do we need to have in a class so that at least two receive exactly the same score on the final exam if the scores are between 0 and 100? 101 plus 1. 101 plus 1. ليش؟ لأنه from 0 to 100 how many numbers do I have? 101 صح؟ 101. So basically here it's 101 plus 1, which is 102. Okay, so 102 students. Okay, طيب. Let's now move on to the generalized pigeonhole principle. Now, the theorem in the generalized pigeonhole principle says the following: if n objects are to be placed into k boxes, then there is at least one box containing at least the ceiling of n over k objects. There is at least one box that contains at least the ceiling of n over k objects. طيب. By the way, the proof for the generalized pigeonhole is exactly using the same lines as the proof of the simple pigeonhole principle. You basically assume that the contrapositive. So basically you negate this. Containing at least the ceiling of n over k, you're going to say إيش? At most the ceiling of n over k minus 1. Okay? And then you follow the same line, you will reach the same result. You will see basically you will have less than n objects. If you count them, you will basically have less than n objects. So I'm not gonna write the proof. طيب. Here you need to make sure of the following. Problems in this category are of the following form, and you really need to identify, what is n, what is r, what is k, right? So usually it is find the minimum number of objects, which is n, such that at least r of these objects must be in one of k boxes, must be one in one of those k boxes. طيب. So what does it mean that the ceiling of n over k equal r? Let's put it this way. So ceiling n over k equal r. What does that mean? What is this equivalent to? Chapter 2. الشباب اللي بدهم نفصل الماتيريال. هذه من chapter 2 صح؟ What does it mean إنه ceiling n over k equal r? الديفينيشن تبع السيلينج ايش هو؟ ما في وين التو، ما في وين سيرة التو؟ n over k is greater than, so this is equivalent to n over k is greater than r minus 1 صح؟ is greater than r minus 1 less than or equal ايش؟ less than or equal r. Okay, less than or equal to r. So now if I need the minimum n, I should concentrate on what? I should concentrate on this inequality صح ولا لا؟ اللي هي n over k greater than r minus 1, which is the same as n greater than k multiplied by r minus 1. So if you want the minimum n, what should you do? K multiplied by r minus 1 plus 1 مثل ما عملنا بال pigeonhole العادي صح؟ Exactly the same. Exactly the same. So let's take some examples. What is the minimum number of students required in a discrete math class to be sure that at least 6 will receive the same grade if there are 5 possible grades A, B, C, D, and F? So basically, from N to R to K, what are we looking for? N, صح? So N is not given. N is what we want to find. طيب, what is the value of K? The K is 5 because I have 5 possible grades, A, B, C, D, F. These are my boxes, صح? These are my boxes. So what is the value of R? Oops. The value of R is 6, right? خلاص. So basically, what do I have? I have N divided by 5 ceiling is equal to إيش? Is equal to 6. What does that mean? Well, this is equivalent to N over 5 is less than or equal to 6, greater than 5. If I want the minimum N, I will say N should be greater than 5, or N over 5 should be greater than 5, which is equivalent to N is greater than 25. What is the minimum N which is greater than 25? Therefore, the minimum N, the minimum N is 25 plus 1, which is 26. Okay, شباب? Any question? طيب. Okay. نعلمكم شدة شوي. This is, by the way, very important. Because I might have, you might see any questions in the quiz or in the exam. I'm not going to repeat the definition of what is a suit and what is a kind. Okay, so here, this is some card terminology. A card deck consists of 4 suits. Each one of those is called a suit. Okay, each one of those is called a suit. So this is the spades, the hearts, the diamonds, and the clubs. Okay, each one of these are suits, and each suit contains how many cards? 13. Huh? Each suit contains 13 cards each for a total of 52. Kinds, now we're not going to see kinds here, but we're going to see them in chapter 7. Kind is basically, for example, the ace, the 1. So no, the ace, the 4 aces are considered as one kind. Okay, the 4 fives, the 5 of spades, the 5 of hearts, the 5 of clubs, and the 5 of diamonds, these are considered as one kind. Okay, فهذا الديفينيشن تبع الكايند والديفينيشن تبع السوت. ان شاء الله we'll come to the kind later. طيب, so let's take now this example. So how many cards must be selected from a standard deck of 52 cards to guarantee that at least 3 cards of the same suit are chosen? 3 cards of the same suit are chosen. So here, who's going to tell me from N to R to K? First of all, what do we need to find? The N, صح? Again, it's the N that we are trying. It's the N that we are trying to find. So N is what we need. طيب, do we have K? What is K? 4, صح? Because we have 4 suits. K is equal to 4 suits. طيب, what is the value of R? The value of R is 3. That's what I want. I want to have at least 3 cards of the same suit. So therefore, R, which is equal to 3, should be equal to ايش? The ceiling of n over 4, صح? The ceiling of n over 4. Now, what is this equal to? So basically, n over 4 should be greater than 2, less than or equal to 3, صح? So let's concentrate on that inequality. So n over 4 is greater than 2 if and only if n is greater than 8. Therefore, the minimum n is equal to 8 plus 1, which is equal to 9. Okay, which is equal to 9. Any question? طيب. Yes.
So we need to at least 9 cards.
Yes, if you pick any 9 cards, 3 at least, you will have 3 of the same suit. ليش? In the worst case, what will happen? 2, 2, 2, 2, صح? 2, 2, 2, 2, and then the 9th will belong to any of the 4 suits. صح?
I misunderstood the question as 3 of a specific suit.
No, it's not 3 of a specific. It's basically this one. How many cards must be selected from a standard deck of 52 cards to guarantee that at least 3 hearts are selected? To guarantee that at least 3 hearts are selected. Do you think we are going to use a generalized pigeonhole here? What is the worst case in this case? 13 13 13 صح؟ مظبوط يا شباب؟ لأنه because now I'm not saying 3 of the same suit. I have only one box. The K is equal to 1 in this case. صح ولا لا؟ The K is equal to 1. ف I have well, here K is equal to 4, but basically I want 3 of a specific suit, which is hearts. In this way, I cannot use the generalized pigeonhole principle. I have to go with the worst case. What is the worst case? Is to basically draw all the spades, diamonds, and clubs, before you start drawing the hearts. So therefore, it will be what? It will be basically 13 plus 13 plus 13 plus 3, right? That's the worst that can happen, which is equal to 39 plus 3, which is 42. So if you pick 42 cards from a deck of cards, you're going to be sure that you will have at least 3 hearts. You will have at least 3 hearts. Okay? Any question يا شباب؟ طيب. Okay, so let's stop here, just like where I stopped in the other section, and let's take our quiz, because our quiz will be 25 minutes. So let me just close the